Hi folks. Today we're going to learn about a new method to solve systems of equations called the substitution method. So let's get started. Anytime you're dealing with a startup business, basically you're trying to make your business profitable. And so we have an example here of Riley's runners creating these running parachutes for extreme athletes. And can Riley create a profitable business? Well, things that you have to take into account are things like rent, and so in Riley's case it's going to be $10,000 for the rent there, and projected cost to produce each parachute, running parachute I should say, is $7. So if Riley plans to set the price at $83, how many running parachutes would Riley's business need to create in order to become profitable? And then also using that information, is it actually feasible for Riley's runner's business to remain profitable for years to come? So are we getting too far beyond our capabilities? These are all questions businesses ask before they even start up. So, in order to do this and look at that problem, we're going to actually look back as to what a system of equations is and how we approach these at the beginning. So, assume we want to find the solution to the system of equations with 4y minus x equals 7 and 3x plus 5y equals 2. Usually we looked at the graph, and if we found this nice point where the intersection lied, we could just say the answer. Well, in this case, though, if you look, our intersection point is not at a good spot here for us to locate the answer. So we need another method. And that's where this substitution method comes into play. So the steps to a substitution method is basically you begin by solving for one variable in terms of the other. And it doesn't matter which equation you use, but you just pick one and then you solve for it. And then you're going to substitute that equation for the variable you just solved for. And this will create an equation in a single variable. Now, with that equation in a single variable, obviously we want to try and solve equations that are in a single variable. And once we have that solution, it won't matter which equation we're going to substitute back into, we're going to take that variable we solved for, plug it into either one of the equations, and find our answer. So, let's take a look. Looking at this problem, step 1 says we need to solve for a variable. Well, if you look at solving for a variable, you're looking for a variable that has just the constant 1 or negative 1 or some multiple there, and usually you won't even see that because 1 times a number just remains that regular number. So in this case, if you look at the first equation, x seems to be the variable we shall solve for. So we get 4y minus 7 actually equals x. That's just moving some variables around there in the constant term as well. Now we want to substitute. So if you look at the second equation, we have 3x plus 5y equals 2. We want to substitute in for that x in that second equation. So just like you have substitute teachers filling in for other teachers, your regular teacher, and we get all excited, we get excited for the substitution method whenever we have a variable so we can plug it in, substitute it in there. So we get, with our second step, the x is now replaced with 4y minus 7, so it's 3 times the quantity 4y minus 7 plus 5y equals 2. Now with the third step, basically this just becomes a try and solve this problem. And so we get 12y minus 21 plus 5y equals 2. Making that a little bit simpler, we can turn this into 17y minus 21 equals 2, or in fact this is 17y equals 23, and we have our answer for y equals 23 divided by 17. After dividing 17 by both sides, from both sides there. So moving on to the final step, we need to take this value and plug it back in. Does it matter which equation we plug it into? No. And in fact, if you look back at step 1, we have a nice easy way of getting x. And so we have x equals 4y minus 7 in that case, and we plug in y for that, and we get 4 times the quantity, 23 over 17, because that's the solution we found, minus 7. Just plug in, get a common denominator, then all of a sudden you get x equals negative 27 over 17. And so what this means is our solution to our system of equations is actually that negative 27 over 17 and 23 over 17 as our ordered pair. So now checking that solution, how do we go about doing that? Well, we just plug in for x and y and just double check to make sure it works for both equations. So if we plug it into equation 1, what do we get? Well, we get 4 times the quantity 23 over 17 minus that negative 27 over 17, since that's the x value, equals 7. And if you actually multiply and do that little bit of division there, you simplify, all of a sudden we'll realize we get 7 equals 7, meaning this is true for equation 1. So it satisfies that first equation. We can also do the same thing for the second equation, just plugging in. So we get 3 times negative 27 over 17 plus 5 times 23 over 17, and that equals 2. But if you notice the left hand side, that equals 2 when you plug all that in. So you get 2 equals 2, so it's true. So that means since it satisfies both equations, we actually do have negative 27 over 17 and 23 over 17. That ordered pair is actually a solution to our system of equations. So moving forward from here, let's see where substitution method can extend beyond to just linear equations. So let's say we have a quadratic involved. So you have negative 3 equals 3x minus 2y, which is a linear equation. But then we have y equals x squared plus x minus 1, which is quadratic. So if you get this graph, things are a little bit nasty. There's no way we're going to be able to figure out the intersection points real quick. So moving forward, how do we actually go about doing this? Well, notice we already have y equals. That's the equation we're going to use to plug in. Moving forward from there, now we're going to substitute in for y. So we're going to use equation 2, substitute in for the y in equation 1. And so we have negative 3 equals 3x minus 2 times that quantity, x squared plus x minus 1. And if we make sure to distribute that minus 2 to the x squared plus x and minus 1, and then move everything over to one side, we should have 2x squared minus x minus 5 equals 0. And so that's just doing some simplifying there. Now, moving forward, how do we solve this? Well, we need to use the quadratic formula. And if you notice, you get a, in this case, if you have an ax squared plus bx plus c from the quadratic formula, your a value equals 2, your b value equals negative 1, and your c value equals negative 5. So, what does this mean? Well, this means we get x equals, if you recall the quadratic formula, is negative b plus or minus square root b squared minus 4ac all over 2a. And so that gives us negative 1, since our b value is actually negative 1. Then we take our plus or minus and our square root b squared. Well, b is once again negative 1. So we square that. Minus 4 times a times c. A is 2 and c is negative 5. And then all over 2a, which is our a value is 2. So if you simplify that, you get 1 plus or minus square root of 41 all over 4, meaning we have a nice solution for our x values. Now we need to find the y values that correspond to that. Well, notice we have two x values, so we'll have two y values. And so the first one we'll start with is when x equals 1 plus square root of 41 over 4. And what does that mean? Well, you can plug it into either equation. I would suggest the easier one of the two would probably be the top one, since you have just a linear equation. But you have the option to use that second equation. So we'll stick with the first equation in this case. So we get negative 3 equals 3 times that quantity, 1 plus square root of 41 over 4 minus 2y. A little bit of simplifying here. If you multiply that 3 up on top and move it over to the left hand side, now we're about ready to solve for y. We just need to combine that negative 3 into that fraction. So negative 3 is the same as negative 12 over 4. Remember to distribute that minus sign, and then we get negative 15 minus 3 times the square root of 41 all over 4 equals negative 2y. Divide both sides by negative 2, and we get y equals negative 15 minus 3 times the square root of 41 all over negative 8. Notice there's both a whole bunch of negative signs there, so we can just kind of cancel out those negative signs and make it 15 plus 3 times the square root of 41 all over 8. And this leads us into our next equation. It's more of the same. Basically, the only difference is you have a minus on the square root now. So all the negative 15 business minus, instead of minus 3 times the square root of 41, that's going to turn to plus 3 times the square root of 41 at the end of the day. And then now we divide both sides by negative 2, and we get negative 15 plus 3 times the square root of 41 all over negative 8. Just some people might not like that leading negative, so you just divide both sides by the negative, meaning we'd finish with 15 minus 3 times the square root of 41 all over 8. So what does this mean? Well, this means we actually have two ordered pairs. With our quadratic being involved with one of our equations, we have two solutions for that system of equations. And those two ordered pairs are, notice how we paired our x and y values. So our first case is 1 plus square root of 41 over 4, along with 15 plus 3 times the square root of 41 all over 8. And our second order pair would be 1 minus square root of 41 over 4, and then 15 minus 3 times the square root of 41 all over 8. So for our second order pair. So this finally leads us back to our first problem with Riley's runner's business. We need to try and find some sort of system of equations and then solve. So notice you start with $10,000 for rent. That's a fixed cost. So that's not going to actually change at all. The thing that's changing is the $7 for the cost, right? And then the $83 for the revenue, essentially. 83 per item and then $7 per item. So the key component here is the item and the total amount of money, whether it's cost or revenue. So X we're going to let denote our number of running parachutes. That's our item that Riley's Runners is making. And Y will be that total amount of dollars. So notice in our first case we get Y equals 10,000 plus 7X. The 10,000 coming from the rent plus 7 times the number of parachutes. And the Y value once again is just the total amount of dollars, or total cost in this case. In our second case is the Y's once again a number of dollars, but it's actually representing revenue in terms of revenue dollars, and it's 83 times the number of parachutes that are being bought up. So moving forward, how do we solve this system? That essentially solves our problem, and this one's actually quite easy. We already have our first step. You can choose either equation, but I think the second equation is easier to deal with, so we'll deal with that one. Y equals 83x. Plug in and make our substitution. So we get our new equation will be 83x equals 10,000 plus 7x. If you just move that 7x over to the one side, you get 76x equals 10,000. So now just divide both sides by 76, and you get x equals 10,000 over 76, and that's about 131.58. Now remember, x represents running parachutes, so that doesn't make much sense. We'll end up dealing with that when the time comes. But if we were to have that exact number, we can plug that back in. You can choose either equation, but the 83x once again is easy to deal with, so we just plug that value in, and we finish with approximately $10,921. There is some change involved there. But in actuality, we're looking for that break-even point, or where the profits begins to occur. So you can't have 58 hundredths of a running parachute, so you build the next biggest one to start become profitable. So what happens is Riley's Runners will begin to become profitable if it can sell 132 running parachutes, and that's a reasonable number. So it seems like there could be a profitable business if you actually can have a market for this, where people want to start to purchase this item. So all things to keep in mind, and hopefully this gives you some idea of how to work the substitution method.